So this video is based on the topic of Flajolet Martin Distance Algorithm. So as you all can see, the Flajolet Martin Distance Algorithm approximates the number of unique objects in a given stream or a data set in one pass. So if stream contains n elements with the m of them are unique, this algorithm runs in a O of n time and it needs a O of log of m memory. So it is a technique which approximates the number of distinct elements from a stream in a single pass. So what Flajolet and Martin are the authors who has invented this algorithm to identify the distinct elements from a given stream. So as you all know, this algorithm works on a big data where the data set or a stream consists of number of elements from where we need to find out the distinct or the unique element present in a given stream. So to solve this algorithm or to learn this algorithm, we are solving one problem. So if you can see here, we have an input stream X in which we have different number of elements present over here, 1, 3, 2, 1, where the number of elements are repeated. So from this stream, we will identify the number of unique elements present in this. So while solving the problem, the stream is given and the hash function is given. So the hash function is a combination of ax plus b mod c, where a is r is 6, b is 1 and mod c is 5. So this is the hash function given. So whenever the problem is given to solve by using Flajolet Martin Distance Algorithm, the stream is always given and the hash function is given. So from this hash function, applying this hash function on a given stream, we have to identify the unique elements from a given stream. So what are the different steps to solve this problem? So first, evaluate the stream in a given hash function for every element. For a given quotient, identify its binary representation. Then for its binary representation, we'll identify its trailing zeros for every binary number. Then we'll identify the maximum trailing zeros from a given table. So for that maximum trailing zeros, it represents as a small r. We'll put the small r in a given formula, capital R equals 2 raised to r. So finally, my capital R represents the unique number of elements for a given string. So this is how we solve the problem. So as our hash function is h of x 6x plus 6x mod 5. So my x is what? I will put the value of 1, 3, 2, 1 inside this x. So h of my first element from a given string is what? 1. So h of 1 we will identify, next h of 2, similarly h of 3, h of 4 and so on. So as this problem, by looking at this, I know the unique elements are 1, 3, 2, 1. So as a theoretical point of view, I'll put the value 1, 3, 2 and 4 in a given hash function. So h of 1 will be 6 into x, which is 1 plus 1 mod 5. So after evaluating the hash function for a value 1, I am getting result as 7 mod 5 equal to 2. Similarly for h of 2, the value is coming as 19 mod 5, 4. Similarly h of 3 is 6 into 3 plus 1 mod 5, I am getting result as 3. h of 4, 6 into 4 plus 1 mod 5, where I am getting result as 25 mod 5 equal to 0. So mod gives me the remainder, which I am getting here as 2430. So for 2, the binary representation is 0010, for 4, 0100, for 3, 0011, and for 00000. So now from this binary representation, trailing 0 means what are the zeros I can see at the end of this string. So here I can see one number of 0 I have in this given binary representation. So trailing zeros are 1. In this I have 2 trailing zeros, so I am writing 2. Here no zeros, so 0. And for all 0, we will write 0. So even if I have here n number of zeros, here the value will be 0. So after identifying trailing zeros, we have to look for a maximum trailing zero value from this. So 2 is the maximum trailing value 0, I can see. So this is my small r. So maximum value from a given trailing zero, which is small r, is equal to 2. So my formula is capital R equal to 2 raised to r. So by putting the value of small r in a given formula, I am getting value as 4, where capital R is 4. So this capital R gives the number of unique elements in a given string x. Thus, the distinct element in a given stream is R equal to 4, which is the number of distinct elements are 1, 2, 3, 4. So this algorithm, as you can see, as the formula is capital R equal to 2 raised to R. So this formula always gives the approximate number of unique distinct elements from a given stream. So even if our stream consists of odd number of elements, it will always give us a unique number of elements as a result of my capital R. So we'll stop here. Thank you.